evaluate the following definite integrals. In part A, we got definite integral of e raised to v plus 5 from negative 3 to 1. We know that when we have just only ex, then integral is ex, but we got plus 5, so do not assume there is formula for everything. So what we can do here is b plus 5. How about recalling this? When we have x raised to a plus b, that is same as x raised to a times x raised to b. If we do that, we get e raised to v times e raised to 5. And e raised to 5 is a number. That's a good news. And that number can be pulled all the way outside. Okay, so let's do that. So this is same as negative 3 through 1 e raised to v times e raised to 5. And I want to write that to the front. This is a decimal number, dv. Now this one is just like ex. So e raised to 5 outside, I'm going to take antiderivative of ev, which is just ev. And we need to evaluate from negative 3 through 1. Okay. E to the 5 is outside. Now these are v, the variable v in this case. E raised to 1, upper limit, minus lower limit, e raised to negative 3. Okay, now we can simplify. In fact, we can distribute because we got all e, same base. E to the 5, e to the 1. And looking at this one, if we go backward, we can combine the exponents. So e to the 5th times e to the 1 is e raised to 6 minus e to the 5, e to the negative 3. 5 plus negative 3 is 2. So e squared. So e raised to 6 minus e squared. Okay, this is not e to the 4. Okay, that's not true. And by the way, this is it. Because e raised to 6 is a decimal number minus e raised to e square is also a decimal number. This is it. The best you can do is e square, we can pull e square out. That makes e to the 4th minus 1, but this is no better than this, so you may leave here. Okay, we got a product. There is no product rule, so we must get rid of this product first. So let's multiply these. 6x minus 3 and 8x squared plus 3. FOIL. So we multiply this and this, okay? So I'm going to write over here whatever I get. Then we'll integrate after that. 0 to 2. When we multiply 6x, 8x squared. 6 times 8, 48 x cubed. 6x times 3, 18x, minus 3 times 8x squared, minus 24x squared, minus 3 times 3, negative 9. So this is the expanded form dx. There are no like terms, so let's integrate each term, okay, because these are all polynomials. So we can simply use the power rule. When we have xn, the antiderivative is just xn plus 1 over n plus 1, as long as the bottom is not 0. So we get here, so I'm going to integrate. So 48 times x, because when we have a product with the constant, we can leave the constant and just do for the function. This is x 3 plus 1, 4 divided by 4 plus 18x, 18 times x means x raised to 1, x is square over 2, 1 plus 1, 2 over 2, minus 24 times x 3 over 3 minus 9. We know that antiderivative of constant is constant x because derivative of 9x is 9. Now we need to evaluate this from 0 through 2. we replace x throughout by 2 minus replace throughout all x throughout by 0. Okay, let's do that. In the meantime, we can simplify. Looks like 4 goes once, 4 goes twice, 12 times. 2 goes once, 9 times. 3 goes once, 8 times. So this is in fact 12x4. Now we are replacing x by 2. So 12 times 2 raised to 4 plus 9 times 2 squared minus 8 times 2 cubed. You can do this in your calculator, don't have to show this word. Minus 9 times 2. That's the upper limit part. Minus replace x throughout by 0. Each term has x, and when we replace x by 0, 0 times a number is 0, so there is nothing. Now punch this in your calculator. 12 times 2 raised to 4, okay, that's 192. 36, 864 minus 18, and that gives us 146 as the final answer.